Okay, welcome everybody today. Today we'll be talking about parts of speech. And we'll start with an example. So you might say something like, my cat who lives dangerously no longer has 9 lives. What stands out to you about this this sentence, aside from the fact that it depicts a totally unrealistic state of affairs? What do you notice about it? Well, as somebody who's trying to implement language technologies, what problem does this sentence raise? Oh, you can't see this sentence. Oh, that be a problem. Okay, we're going to have to try something else here. When other people do it, like recording lecture, seems so easy. But when we do it, it's impossible. It's not just me. I mean, I'm bad, but Professor Black, I mean, he's pretty much given up. It's true. Let's see. What can we do? Okay. Ah. Okay, I'm going to do something extremely weird looking. Oh.
I think you need to try changing your source again.
Source here?
Yeah. And try I don't know, desktop. Oh, you need to add.
Oh, add, yeah. Yeah. That might help. So there's not a desktop one. There's display capture, which is what I was trying. And then there's window capture.
You try window capture.
So let me try that again. That's what I was trying before, but the window I was trying to capture was not showing up. There it is. Okay. We'll try that. Okay, so as we were saying, so as after that break where we, am I still recording here? Yes. After that break, you should have figured out, you should have been able to read my mind and figure out what it is about this sentence that is notable. Yeah.
So lives and lives are like spelled the same, but they're two different things.
Right. So if you naively treat words as things that are orthographically the same, you run into some problems. And one problem is that they may not be of the same part of speech. So you've got lives and lives. And lives is what part of speech? My cat who lives dangerously, that's a verb. And lives is a noun, a plural noun. So in this case, they're also pronounced differently. So the noun is pronounced lives, the verb is pronounced lives. And that's only one example. So here's an example wherein I make fun of Alan. So Mr. Black used to have a black beard, but it is less black now than it used to be. He might black out if he realizes this fact. So what parts of speech are exemplified by the word black here? So first we've got Mr. Black. That's going to be a proper noun, and black beard, adjective. Less black, adjective. Black as in blackout, verb. Okay, so one word can have, one orthographic word, that is a word that's spelled one way, can have multiple different parts of speech. This is a fundamental problem of NLP. This is the problem of part of speech disambiguation. Figuring out, given a particular word and its context, what the part of speech of this word is. This is the basis for a task that's been very important in NLP, and that is the part of speech tagging task. So basically, you're presented with a sequence of words, tokenized words. So words divided into units. And then the output must be a sequence of part of speech tags of the same length, one per word. So you're given the words in some kind of context, in a stream of tokens, and you've got to figure out programmatically what part of speech tag goes with each word in that stream. Now, this task is actually not super simple. It's something that we can do well for languages where you have a lot of training data. So for English, you can get, on this task, you can get rates, well above 90%. But you have a large body of data to train on. If you have less data, then this becomes a more complicated task. And there are a variety of linguistic factors that enter into this. And there are languages that are structurally different from English too, where this becomes more complicated. And we'll see in this lecture and in a following lecture why that might be. But for our purposes, for this lecture, this is how we'll define the task. We assume that there is a right part of speech for each word, and that we can find it and verify whether we've found the right part of speech for each word based on ground truth. That's what we're going to assume in this task. So here's an example. says Charlie Brown received a Valentine. So each of these words is a token. So we want to assign a part of speech to each of these words. So Charlie and Brown are both proper nouns. Received is a verb. A is a determiner. Valentine is a noun. And punctuation, period is punctuation. Now we could get more fine-grained than this. And actually some part of speech tagging tasks require more fine-grained analysis than just proper noun, verb, determiner. In fact, one of the biggest sets of data that is used for part of speech tagging is the data from Penn Tree Bank and for English. And it has a much finer grained system of part of speech tags, as we'll see. So there's this guy named Ron Kaplan. And Ron Kaplan was an important figure, or has been an important figure in NLP for a long time. He was important in developing finite state methods for morphology and phonology. He developed some early approaches to syntax from a computational perspective. And now he is a vice president at Amazon. He's in charge of Amazon Search. But he is a linguist at heart. And so he liked, when he was interviewing people at the various companies where he's worked, he liked to ask them questions. Like if somebody came in and he asked them, "What do you work on?" And they said, "Oh, I work on part of speech tagging." Then he famously asked the question, "What's a part of speech?" And a surprising number of people who were asked this question were unable to answer it. And I don't want you to go away from this lecture not being able to answer Kaplan's question, what is a part of speech? So listen closely, because if you ever get interviewed by him, you'll want to know this information. So what are parts of speech? Well, you might think that words in a language are all, kind of in a big cloud. They're sort of fuzzy. Language is messy, all of that sort of thing. We can't really categorize them. We can just say that some are more similar to others than is generally the case. But this is not actually how languages work. In actual fact, if language is like a soup, it's not like a tomato soup. It's more like a stew with lots of chunks in it. Or curry. It's got subcategories and structured subcategories within those subcategories. And even if some things are kind of soft here and there, they still have form. And if you miss this fact, if you miss the fact that language is structured in this way, that the lexicon, the set of words in a language, have this kind of structure, you're just making things difficult for yourself. Because this structure is real. So what are parts of speech? So basically when we say this, well, what did your English teacher tell you about parts of speech? What were the parts of speech that you were taught when you were either learning English as a second language, or when you were learning how to use English as a first language speaker for the 1, 2, 3, 4, 5, 6, 7, for the relatively few of you who, for whom English is your only first language, people who, what did your English teachers tell you about parts of speech? What is a part of speech according to them?
They had certain functions,
Okay, they had certain functions like what?
like a verb denotes action.
Okay, so verb is an action word. What about a noun?
Okay.
An object?
Could be a subject, no?
You mean object in terms of the two meanings of object, at least for our purposes. Do you mean like a thing, or do you mean like a grammatical object?
Okay.
A thing. Okay, so it's like a thing. Like I was always taught it's a person, place, or thing, or abstract concept if you had a really radical English teacher. So what about adjectives?
Describe nouns.
They describe nouns. So these are all lies. In fact, English teachers are liars. That's what they do. They're paid to tell well-intentioned lies. So, like we think of nouns as things and verbs as actions. But what about walking? If I said, my walking upsets her, is walking a noun or a verb? It's a noun. You can say, my walking. It's like, but is it a thing? It's really an action, right? But it's a noun. So, you're taught often when you're learning these things from well-intentioned teachers that parts of speech are about meaning. That it's about a verb is about actions. Lots of verbs are not about actions. What about the verb to be? As in, I am a systems scientist. Is that an action? It's not an action. It's a state of affairs, but it's not an action. The parts of speech are not about semantics. What are they about? They're not about meaning. Instead, they're about two different things: distributions and morphology. So by distribution, we mean that if two words are a member of the same part of speech, they occur in the same kinds of contexts. So we'll talk later in the course about word vectors and word embeddings. And you take the context of a word and look, of let's say two words. Usually it's a whole corpus of words, but and you look at the words that occur around them and quantify, project them into vector space based on the words that occur around them. If you have a narrow window when you do that, you just take words on, like one word on either side of the word you're concerned in, and look at its context through a huge collection of text, a huge corpus. Then you'll find that correlates to a relatively high degree with part of speech judgments. Because part of speech is partly about distribution. That's actually the big thing. This is even more evident if you do some kind of syntactic analysis on the data. And you can tell whether something occurs as the subject, for example, or the object of a sentence. And if it occurs as a subject or an object, then it's going to be a noun. If it occurs as a modifier of a noun, a modifier of a subject or an object or an indirect object, it's going to be an adjective. If it modifies, if it's in a position syntactically where it modifies a verb or an adjective, it's going to be an adverb. If it is sitting above a noun in the syntactic structure in a place where an adjective can come in between, but nothing else really, it's going to be a determiner. So the distribution, both in terms of what words come before or after a word, and the distribution in terms of what syntactic contexts, what parts of these trees of the sentence a word can occur in relative to other words give us parts of speech, at least one half, the larger half, really, of parts of speech. The other thing is that if something is of the same part of speech as another word, those words tend to allow the same prefixes and suffixes. That is, they tend to share similar morphology. So here we're looking inside the word. With distribution, we're looking outside of the word. But all of these are similar formal criteria that are not semantic. It's not about semantics. If you go down the semantic route, it will lead you to insanity. It will. You know, you just deal with so many counterexamples and so much problem that it's not cool at all. So let's talk about what some parts of speech are. And we're going to start by a division into what are called open class and closed class parts of speech. So you can divide the lexicon, the set of words in a language, into the open class words, which includes most words, and closed class words, which includes a few words. Open class words are words that you can, classes of words that you can easily add to. So you can coin new open class words. Closed class words are ones that you can't make up new instances of. You can, they can develop over time, but it's very hard to introduce a new closed class word. So probably the most open of the open class words or classes are nouns. You can make up new nouns all the time, right? You probably make up a noun a day, if not 2. I made up 3 nouns just this morning. You know, it's a very open class. But you can always tell a noun. And one way that you can tell a noun is all nouns can be both subjects and objects of verbs. All nouns can also be the objects of prepositions. Most nouns can be either singular or plural, though there are exceptions. So you can say my dog and my dogs, but you can say my information, but you can't say my informations. And that's because information is a special kind of noun called mass noun. But they can have determiners like the and a. They can be modified by adjectives. And they can have possessors. So you can say my book, John's book. All of those are true of all nouns except for the plurality thing. So this gives an example of how we might define a part of speech. We can define certain tests that can be used to say whether something is a noun or not. And these are the sort of tests that somebody would use when they're creating data, like training data or test data, for part of speech tagging or other tasks that require parts of speech. Sounds sort of tedious, right? Sounds like something somebody else should do. Well, I've got news for you. No, we're not going to make you do part of speech tagging. We used to make people do NER. That was bad enough. We're going to make you do part of speech tagging. We're not going to make you do it by hand. We give you training data and stuff. So English verbs are words that they take at least the subject. So syntactically, they take at least the subject. Sometimes they take 1 or 2 objects. So you can say things like, Dr. Mortensen parsed the data, or Professor Black passed the function in an argument. They can also take tense morphology. So all verbs in English can be either past or non-past. among other things. They also have participles, present and past participles. And they can be modified by adverbs. True of all verbs. So if you can't do any of those things, you're not a self-respecting verb. Then we have adjectives. Adjectives modify nouns. That is, they restrict what those nouns can refer to. And you can use them in two different ways, all adjectives. So they can be used attributively, so you can say his pitiful code, or you can use them predicatively, with the verb to be. So you can say things like his code is pitiful. You can also, they share something in common morphologically, which is you can add these and us suffixes to them. So you can say big, bigger, or biggest. But you can't do that with all adjectives. You can only do it with little adjectives. So bigger adjectives, like pitiful, you have to say pitiful. You can't say pitiful, pitifuler, pitifulest. For prosodic reasons, you have to say pitiful, more pitiful, most pitiful. So that's not the best test because it only applies to adjectives that are short, that are one or two syllables. So it turns out that not all languages have adjectives. Anybody here speak Korean? Yeah, Korean
Yeah,
doesn't actually have adjectives. It has stative verbs.
I just thought about it and I think you don't.
So they're the words that do adjectival things in Korean that modify nouns are basically verbs, and when you use them, yeah,
I think you can still make distinctions between verbs and adjectives.
in Korean.
Yeah, it ends differently.
But they're the same. It's the same syntax. So when something is acting attributively, then it has different morphology than when it's acting predicatively. But it's not based on an adjective-verb distinction. It's based on, it's based on where it's occurring syntactically. So there are a number of languages that don't have a separate class of adjectives, or where there's not a distinction between adjectives and verbs. Then we have adverbs. So adverbs occur as modifiers, syntactically as modifiers for verbs, adjectives, and other adverbs. So you can say things like, he erroneously concluded that PHP is a real programming language simply because it's Turing complete. But you can also say he concluded erroneously. So they have this property that you have different, you can sequence them differently, but the relationship between the words is the same. You can also have adverbs that modify other adverbs. So you can say my code runs very slowly. So very is not modifying runs. It doesn't run very. It's modifying slowly, which is modifying runs. My code does run very slowly. So those are the important open class parts of speech. Let's talk about some closed class parts of speech. The first of these is kind of the intermediate case. They are prepositions, and in some ways they're like open class, in some ways they're like closed class lexical items. So you can't usually come up with new prepositions, but sometimes people do. So, or they'll change a word from some other class into a preposition. So because was a conjunction, but it's become used as a preposition. So in contexts like I'm failing because TAs. Has anybody heard this kind of construction before? Or I'm stressed out because school. Anybody heard this? So because in those contexts it's functioning as a preposition. And prepositions are generally easier to introduce than other closed class parts of speech. But anyway, basically they occur before noun phrases. And they relate the noun phrase to some higher level constituent, like another noun phrase or a verb phrase. So if you say, I scattered the data from hell to breakfast, which is something my mother would say, except without the data part. We have two prepositions, from hell and to breakfast. And likewise, he lingered in the depths of despair, we also have two prepositions. But here, both prepositions are relating the noun phrases to scatter. And here, you have, he lingered in the depths of despair. So it's relating it to a noun phrase. It's actually not hard to characterize prepositions formally because they occur in such a distinctive position. But they're difficult semantically because they tend to have such abstract meanings. They're not very concrete. Think of the preposition by or the preposition of and try to define them in a way that works for all contexts. Like, if you think of he was hit by the ball or the storming of the castle. It's they have very abstract meanings, and so they're difficult to capture. It's difficult to capture their meaning, but their form is sort of easy to identify. So that is another reason not to try to categorize parts of speech by their semantics, because with prepositions you just lose. But it's very clear formally. They're also often similar to, in spelling and pronunciation, to what are called particles. So there's both a preposition up and a particle up. And we can tell these are different, if you distinguish between he looked up her phone number and he looked up her chimney. So, why are you laughing? So the up there is actually doing a different thing in those cases. In one case, it's a particle. In one case, it's a preposition. In the second case, the prepositions are hard. Let's talk about determiners. So determiners this is not a part of speech category you probably learned in school, but this is a part of speech category that linguists and NLP people use a lot. And this covers both what you might have heard of as articles, like the and and also demonstratives, like this and that, when they're used before a noun phrase, at the beginning of a noun phrase. That version of Python really chaps my hide. Which version is that?
Python 2.
Be more specific.
2.7.
2.6. Because it's missing all of the things you expect, like the good things that were backported to 2.7 are not there. And if you're stuck on a machine with 2.6, it's hell. So English pronouns are sort of words that stand in for noun phrases. They act as a sort of shorthand for noun phrases. So you or your or who, these are all pronouns. So this raises the question, actually, are pronouns open or closed class? So it's hard to come up with new pronouns, but people do attempt to introduce new pronouns, and there's some, for people with different gender identities, they have introduced novel pronouns, and some of these can be used by some people with some facility, but it's actually pretty difficult to get yourself to use a new closed class vocabulary item. So we have conjunctions. Conjunctions join phrases together. It's like you take a phrase of type X and another phrase of type X, put the conjunction together in them, and you get a bigger phrase of type X. These include coordinating conjunctions like and, or, and but also subordinating conjunctions like if, because, though, while, however, and so on. So this is part of my childhood. None of you are old enough to remember this, but Schoolhouse Rock was what brought me to the scientific study of language. And conjunction, junction, what's your function? I would sing it to you, but I have no sense of pitch. So let's talk about auxiliary verbs. These are verbs, but they're special helping verbs. That's what I was taught to call them when I was a child. And some of them can also be main verbs as well, like be and have. But others, which we call modals, only occur as auxiliary verbs. So would, will, could, can, might, must, and so on. Only occur as auxiliary verbs. And what do they do? Well, they add information to a verb. That's what they do semantically usually, is they'll add information about what's called mood, and also they carry tense information a lot of times. But tense and aspect information. But semantically, there are these things that occur before, or syntactically, there are these things that occur before verbs, can carry tense morphology, and occur above verbs in a syntactic structure. Then we have particles. Sometimes you'll hear the word particle used as this kind of grab bag category for closed class items that don't fit into another category. It's very unsatisfying. Most often in English, then, what we call particles are words that resemble prepositions but act in unpreposition-y ways. They're actually more closely tied to the verb than to the noun that follows. Although they can do crazy things, like you can move them to the end of a sentence, so you can say both he tore off his shirt and he tore his shirt off. Then we have numerals. This seems pretty obvious, what these are, but they have properties of both nouns and adjectives. So they can be the subject and object of verbs. You could say, 2 will enter, but only 1 will leave. Or, I bought 20. But they can function both attributively and predicatively like adjectives. So 2 variables were undeclared, or we are 3. And when they're used attributively, they come before any adjectives. So you say, the 2 undeclared variables were the cause of much consternation, but you cannot say, and that's what the star means, the undeclared 2 variables were the cause of much consternation. We all agree that's bad? You can't say that? Yeah. So why do we care about parts of speech? I've been telling you, there are these parts of speech, there are those parts of speech, this is how you can tell them apart. You're probably thinking, this is exploring when am I going to use this in the project. Is this really going to be on the test? You know, yes, it will be on the test. You will use it in the project, indirectly at least. But why do you care about parts of speech when you're doing NLP? Well, read the slide to me. So there are lots of words. There are many words. There are too many words. So what if you just train a system on words directly? If you have a lot of training data, this is not such a problem. But let's suppose you're working in a domain with a limited amount of training data, or in a language with a minimal amount of training data. What are you going to do then? So if you're just making all of your generalizations, if your system just has to generalize based on individual words, let's say you're writing rules, just to introduce a fanciful example. And you're writing rules for a language, for some task in the language. And you have to write rules for each word, like for parsing the syntax of the language. Would this be a good idea? What's the problem with that?
You'd have to redo the work for each word that's similar.
It'd be kind of redundant, wouldn't it? You know, if there are classes of words and they all behave the same, and yet you're writing a rule or having to learn a generalization for each one of them, this is kind of a waste. This is sort of stupid. It's not just stupid, it's idiotic. You know, and part of speech is one thing that allows the generalization of models. So if you can tag things for part of speech, then you've got a smaller number of categories that you can then generalize over. And so this can result in much smaller models that can be trained on much less data. The bad news, in a way, is that there are many different tag sets that are used for part of speech. And you have to use the one that is used in your training data, or something that you can transform that into. But you also have to use the right one for the task that you're using, that you're doing. So how might tasks, what kinds of tasks might use part of speech? Yes?
Name entity recognition.
So named entity recognition definitely can benefit from part of speech, because if you can narrow down words, just the words that are nouns, then you can ignore a lot of other stuff and just focus on classifying those nouns. So yeah, definitely. What else?
Word sense disambiguation.
Word sense disambiguation. Why is that?
Well, like you said, black could be Dr. Black or black out or the adjective black. So
Right.
you need to know what part of speech the word black is.
Yeah, so that actually goes a long way towards word sense ambiguation. It doesn't do it entirely. You know, you still have cases like bank is in a river bank and bank is in a financial institution, where they're the same part of speech, but you've constrained the search space once you've identified the part of speech. of the word that you're thinking about, that you're trying to disambiguate. What else? Yeah.
Co-reference resolution.
Okay.
You want to be able to find all the pronouns so that you can map them to their nouns they
Yeah,
are referring to.
exactly. Yes.
Sentiment analysis, where you more focus on adjectives, for example.
Right. So if you want to find all of the adjectives, it's helpful to do part of speech tagging and find them that way. And then you can build a classifier, use those as a feature in a classifier in ways that you couldn't if you didn't do the part of speech tagging. Anything else? There are actually a number of others too. But. So like syntactic parsing. If you're trying to, which is important for things like coreference resolution. If you're trying to parse sentences into their syntactic structures, instead of writing rules for individual words or learning rules for individual words, you can learn patterns over parts of speech, and it's much more, you have much better generalization. So how do we know the class of a word? So going back to what we said at the beginning about what made a part of speech, and what we've learned about individual parts of speech, how do we know the class of a particular word?
The position in the sentence,
Right, the position in the sentence.
it would work in English.
Yeah. So it'll work in most languages, although, in some languages you have freer word order than in English. And so you have to define the criteria differently, but in languages generally you can talk about, you can define things about the position of a word relative to other words. And you can define sort of substitution tests. So if you say something like, the adjective cat sat on the mat, then pretty much any adjective can be plugged into here. It's kind of a substitution test. Did anybody here do Mad Libs as a child? As a child, I thought Mad Libs were the best thing ever. They're hilarious. You fill in, so who wants to explain what they are? Yeah, right.
So oftentimes like a short passage, and there are a bunch of blanks that you need to fill in, and so one person will like see all the blanks and they'll say, okay, I need an adjective, I need a noun, I need an adverb, and the other person, without seeing the passage, will like give just any word that fits that part of speech, and then you fill in the blanks and you read it, and it's often sort of silly.
Yes, by which he means hilarious. So basically, that's an example of the same thing. If you can fill in, you can take a sentence like this and substitute an arbitrary word for it, and if it works in all of the sentences like that, then it's that category. Yeah.
Well, doesn't that require that we have this same sentence with different substitutions that we can learn from?
Well, so this is the kind of criterion that would be used by someone who was annotating data to be used, to be trained on or to be tested on. So in terms of how you know how a system knows parts of speech, it's because they're given they're given tagged data and are able to generalize from that. You can't really do substitution tests computationally very well yet. Because you're not going to find in a corpus instances of this that only differ by the one word. Something we'll talk about next time, or Alan will talk about next time because I won't be lecturing, is techniques for actually doing part of speech tagging. The kind of classic technique, not necessarily state of the art, but the easy to understand and still very competitive techniques using hidden Markov models to learn from tagged data, and you can build a perfectly respectable part speech tagger that way. So here's just a summary. So we have open classes and closed classes. Now, open classes are nouns, verbs, adjectives, and adverbs. Closed classes are prepositions, determiners, pronouns, conjunctions, auxiliary verbs, particle verbs, and numerals. Particles and numerals. So any questions about this so far? Do you feel confident that you can answer Kaplan's question? If I ask you, what is a part of speech? Oh, you work on part of speech tagging. What is a part of speech? What would you say? Don't embarrass me here. Yes?
Summarize it as just bucket sorting the language.
Okay.
A bunch of buckets, right?
Yeah, and what is the criteria for the sorting?
Similar usage and places in speech, I guess.
Yeah, so similar distribution, similar morphology. So here's something else we have to know. So sometimes you have a set of tests. They're great tests. They work for most members of a part of speech, but they don't work for all members. So there's a kind of cluster within a category. There's a cluster of tests that apply for everything that you think goes in this category. And then there are instances that for which only some of the tests apply. So for example, for nouns, we said that nouns can occur with determiners. So you can say the dog, the cat. You can't really say the David. I suppose you can say the Donald. But normally, in English, this is not true in dialects of German and Italian, but in English you can't have a determiner with a proper noun. So we really need to have a distinction, a subclass. So we have a superclass nouns that has the most general test. Then we have two subclasses, proper and common, that inherit from that class. And then within common, then we have count and mass. So we talked about how you can say the dog, the dogs, but you can't say the informations. So the information is a mass noun. You can't pluralize it. Count nouns you can pluralize. So you have these, you get tests that count nouns will pass that mass nouns won't. So you have a kind of inheritance hierarchy, these more and more fine-grained classes. Likewise, for adverbs, you have different classes that behave somewhat differently, these directional, degree, manner, and temporal adverbs. But even given that, there are some hard cases. So some of these, it's just, they're not super hard. They just look weird. So I will call up my friend. I will call my friend up. I will call my friend up in the treehouse. So it looks like, up is occurring after friend, looks like it's just a particle just like it, but the structure of the sentence is different. So this up is actually associated more closely with the in the treehouse, and you can test that and show that it's true. So this one is a preposition. So you have to distinguish particles from prepositions. There are also gerunds. So you can say, I like walking. And you can say, I like apples. Right? Any objections? So what about, his walking kept him fit. His apples kept him fit. Fine with those? His walking slowly kept him fit. His apples slowly kept him fit. So for me, those are both okay too. But the structure of those two sentences is different. So his walking slowly kept him fit. His apples slowly kept him fit. So slowly is in the first sentence is modifying walking, and the second sentence is modifying kept. So it's kind of weird. Walking is being possessed like a noun, but it's being modified by an adverb like a verb. So earlier I said walking, is a noun. Well, it's sort of a verby noun, or it's what's called a deverbal noun. So what do you do about these? I've got an answer for you. You don't care. Because it's sort of in the long tail of the data. This is not, you can just treat walking as a noun and you'll be fine. Unless you're a linguist and your publication record depends on, coming up with some analysis of what walking is. Then, if you're a perfectly respectable NLP practitioner, you do not care. It's just fine. Most of the time. The question is, what do you want out of it? What are you trying to get out of your part of speech tagging? And for most of the tasks that you're interested in, then this issue about deverbal nouns is not relevant. So there are other parts of speech too. So there are interjections, negatives, politeness markers, greetings. There's existential there. It's like the there and there is a thing called existential there. You got numbers. You want to treat probably symbols and money as separate parts of speech. Emoticons, you probably want to give a distinct part of speech, or emoji, as you young people insist on calling it. URLs, hashtags, all of those you probably, for a lot of tasks, you're going to want to treat those as different parts of speech. Not necessarily for every task. So if you're doing co-reference resolution, a lot of this is probably not interesting, because you're mostly interested in nouns and pronouns. But if you're doing sentiment analysis, this might be quite relevant. So how many parts of speech are there? So people disagreed. So Google came along and they decided that they would legislate the number of parts of speech. And so these are the Google Universal POS tags that are used in the Google Universal Dependency Tree Banks. Some of these are concerning, like particle, which is just a grab bag category, and X, which is also a grab bag particle or category. So you don't know which grab bag category to stick your exceptional items in. A lot of people, though, use the Penn Treebank part of speech data and tag set, and it's much more rich. So it has, instead of having, what is this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 parts of speech, it has like 50 parts of speech. They're very finely divided, but you can just take the first 2 characters in the part of speech tag, and it will give you these coarser part of speech categories. So this is what Penn Treebank data looks like with part of speech tags. So you've got NNP for a kind of proper noun, IN for one class of prepositions, so on. So imagine a state of affairs where each word, each orthographic word, each spelling of a word was a candidate for just one tag. POS tagging would be pretty easy. How would you do it?
Just build a map the words to their part.
The lookup table. Yeah. What problems would you have potentially?
Never seen a word before.
Ye-
There's no way to-
Yeah. So if you have out of vocabulary words, you have no way of dealing with them if you're just using the lookup table. So even in this case, it pays to be a little more clever. And as we've seen, you have lives and lies, you have black, black, and black. How bad is this problem of ambiguity? Well, here are the words in the Penn Treebank that have the most ambiguous parts of speech. So down has 7 that set, put, open, hurt, cut, bet, back. I'll have 6, and so on. If you just look at down, then there are 317 instances where it's an adverb, 200 where it's a different kind of adverb, 138 where it's a preposition, 10 where it's an adjective, 1 where it's a verb, and so on. So it's pretty ambiguous. So here we see examples of down with different parts of speech. And Japanese even, with 3 different parts of speech. So how do we do this? How do we do part of speech tagging? So one way of doing this is just to pick the most frequent tag. And that actually gives us about 90% accuracy. So sometimes the dumb solution is not so dumb. It's actually pretty good. But if you want to be smarter than that, if you want to get 97 or 98% accuracy, what do? What information do you need? What do you do that allows you to know the part of speech of a word? You're dealing with the same degree of ambiguity, but you don't have any problem disambiguating the part of speech
Because we have the context.
of words. Because you have the context. So if you have the preceding context in terms of words and the preceding context in terms of tags, then you have a pretty good idea what the word is. So if I say the, if I have a the, and then you're to fill in what the next word could be, what are the options? Could be a noun or it could be an adjective. Or what about to? Could be a verb, could be noun, could be a determiner, could be an adjective. If I say John's blue, it's got to be a noun probably. Or a conjunction. John's blue and red sock. So when we talk next time about HMMs, we'll understand a good way of looking at local context. There are other ways of doing this that are actually more powerful than HMMs, but HMMs are something that you need to understand, and they're relatively simple. So you've got a problem, and that problem is the out-of-vocabulary problem. So how do you handle cases where your dictionary does not include all of the words? This is often the case with proper nouns. It's really hard to list all the proper nouns. It's also with borrowed words. People borrow words all the time. It's hard to list all of them. And people are always making up words too, neologisms. So for you, these are not a problem. You deal with these all the time. How would you give a POS tagger the same superpower that you have? How do you figure out when somebody says a word that you didn't already know, that you've never heard before, how do you know what it means? How do you know? You know at least it's part of speech. You don't necessarily know what it means, but you can at least figure out the part of speech. How do you know? Yes?
From the context, from like where it is in the sentence and what's around it. So
Right.
basically it's like a distribution of how often does a particular part of speech occur in this particular context.
Right. So it's just based on distributions mostly, and sentence structure, but basically distributions. So how would you give a POS tagger the ability to do that?
So we'll manually type in the rules. So after, let's say after the verb, it's high. It's probably be a noun or something.
Yeah, so you could manually type the rules, but there's
But also we could look at our transcend to look
Yeah.
at the data we already have to see the probability.
right. So you could compute probabilities basically of a particular part of speech happening after a particular, a sequence of other parts of speech, and use that to figure out the part of speech of the unknown item, the out of vocabulary word, and that's really what you'll learn how to do that. An elegant way of doing that next time. Okay. So in the last 6 minutes, I'd like to ask if there are any questions about the new homework. Who's had a chance to look at it? Looks like about half of you. So this one is not to be procrastinated. It's my favorite homework, actually. Yeah?
In like actually physically drawing out the transducers,
Uh-huh.
there are a lot of edges to be drawn, and it seems sort of infeasible to clearly label all of them in pictures,
Uh-huh.
unless that would be very long. What exactly do you expect with the drawings?
So for the labels, when you have multiple edges between the same two states, then you
Rather
can,
than that, it's more just like
the number of edges?
yeah, like in one case there's like a fixed node complete graph type thing going on
Right.
the way I did it, and in another case, it's like almost the same thing. It's just really hard to label it using a complete graph.
So people do it. I mean, it's hard to write, right? I mean, it's hard to do it clearly.
Mathematically,
Right.
what the temperature is.
So there are tools that you can use. If you can give the mathematical description, basically the transition table, then you can use like OpenFST to draw the networks with dot. So that's one option if you find it too like tedious to.
Technology, I'm not sure how to cleanly label. Again, complete graph.
Well, the technology takes care of positioning the labels and everything for you.
And I feel like it's something really big or something that's quite an improved issue. But maybe I'm thinking of it.
Don't worry too much about that. And if you you can use various shorthands, like if you have multiple subgraphs that are repeated, then you can draw like one instance of the graph and show how they how the one subgraph and show how to derive the whole graph from that subgraph. You know, you're free to do that. But this has not typically been a problem in the past. You know, people have turned in, for the most part, legible graphs. If you have too much going on, it may be that you don't have the most elegant solution to the problem. Any other questions? So this actually is a fair amount of work to get working. So I suggest that you start on it soon. I'm going to hold a special office hour Tuesday evening, probably around 5. So if you are having trouble, then please stop by then. Otherwise, you know, keep the questions coming on Piazza, and I'll try to answer as many as I can, although the TAs will probably have to answer a lot of them. Okay.